Earthquakes have a profound and far-reaching impact on the field of civil engineering. These natural disasters, caused by the sudden release of energy in the Earth's crust, result in ground shaking, surface rupture, and a range of secondary effects. The consequences of earthquakes for civil engineering are multifaceted, and they encompass various aspects of design, construction, and infrastructure management. Here is a detailed description of the earthquake impact on the civil engineering field. Structural engineering. Earthquakes pose a significant challenge to structural engineers as they subject buildings, bridges, dams, and other infrastructure to dynamic forces that can lead to structural failures. Civil engineers must design structures to withstand these forces through principles like seismic-resistant design and retrofitting of existing structures. Innovations such as base isolators and dampers help mitigate the impact of seismic shaking. Building codes and standards. The occurrence of earthquakes leads to the development and revision of building codes and standards. These codes are continually updated to incorporate the latest seismic research and engineering practices. Compliance with these codes is essential to ensure the safety of structures and occupants in earthquake-prone regions. Geotechnical engineering. Earthquakes affect the behavior of soils and foundations. Geotechnical engineers analyze soil liquefaction, landslides, and settlement caused by seismic events. This information is crucial in designing foundations and retaining structures capable of withstanding ground motion. Seismic hazard assessment. Civil engineers conduct seismic hazard assessments to identify the level of earthquake risk in a specific area. These assessments inform land use planning, construction practices, and the establishment of building codes. Accurate hazard assessment is critical for safeguarding communities. Infrastructure resilience. Earthquakes can disrupt essential infrastructure, such as water supply, transportation networks, and power systems. Civil engineers work to enhance the resilience of these systems, ensuring they can withstand seismic events and recover quickly. This involves retrofitting existing infrastructure and implementing redundant systems. Emergency response and planning. Civil engineers are involved in emergency response and planning for earthquake events. They develop evacuation plans, design emergency shelters, and assess the structural integrity of buildings after an earthquake to determine their safety. Seismic retrofitting. Existing structures often require retrofitting to improve their earthquake resistance. Civil engineers assess older buildings and infrastructure and implement retrofit measures to bring them up to current seismic standards. This process involves strengthening foundations, adding bracing, or modifying structural elements. Public awareness and education. Civil engineers play a role in educating the public about earthquake preparedness and safety measures. This includes promoting awareness of earthquake risks, teaching earthquake drills, and providing information on constructing earthquake-resistant homes. Research and innovation. Earthquakes drive ongoing research and innovation in civil engineering. Engineers and scientists study earthquake behavior, develop advanced modeling techniques, and design novel materials and technologies to enhance seismic resilience. International collaboration. Earthquake impacts are not confined to a single region or country. Civil engineers often collaborate internationally to share knowledge and expertise in earthquake engineering, which contributes to global disaster preparedness and response efforts. In summary, earthquakes have a profound impact on the civil engineering field, influencing everything from structural design and infrastructure planning to geotechnical engineering and emergency response. Civil engineers play a critical role in mitigating the destructive effects of earthquakes, ensuring the safety and resilience of communities in earthquake-prone regions.